And on to question 6. And on to question 6. Continuous random variable x has been a continuous random variable x has, and on to question 6. A continuous random variable x has probability density function f of x as described, where k and n are positive integers. Find k in terms of n. Okay, so we're back to a situation where we know integrating this probability density function in between the maximum and the minimum valid x value should give us an answer of 1. So let's go ahead and integrate our function in between 1 and 0. I know the k is a constant, I'll take that straight out, and I have x to the n dx. Now that should equal 1. So k, when I integrate, I'm going to increase the power by 1, which will become n plus 1, and divide. So I have x to the n plus 1, and I'm going to set the fraction like this. Now, in between 1 and 0 should equal 1. If I substitute 1 into this expression, I'll get k, and then 1 over n plus 1 multiplied by 1 to the power of n plus 1. Now, I recognize that 1 to any power is going to give me a result of 1. So, in effect, I actually have k 1 over n plus 1 equals 1, making k the subject. I can say that k equals n plus 1. So I've multiplied by n plus 1 on both sides. That's eliminated the bracket from the left-hand side and given me k equals n plus 1. And this is what I was asked to do, to find k in terms of n. So my k equals n plus 1. Continuing with the question, I was asked to find the expectation of x in terms of n. Okay, so I can find the expectation of any continuous random variable by multiplying x by the function and integrating in between the maximum and the minimum values. So let's go ahead and do that. Once again, I'm going to take my k outside, which I actually know to be n plus 1 now. And I'm integrating x to the n plus 1 in between 1 and 0. So as I integrate that, I should get n plus 1. Integrating should give me x to the n plus 2 all over n plus 2 in between 1 and 0. Substituting 1 into here again is going to give me a numerator of 1. Substituting 1 into here is going to give me a numerator of 1 to the power of n plus 2, which once again I know will just be 1 over n plus 2, minus 0 substituted into the expression, which will give me 0. And simplifying this, I have n plus 1 over n plus 2. Okay, find the expectation of x squared in terms of n. Going to be a very similar process. Okay, find the expectation of x squared in terms of n. So that's going to be a very similar process. I'm going to integrate, taking the k value outside, x to the n plus 2. So that's me multiplying by x squared. And let's see what we get. n plus 1. Integrating, I'm going to increase the power by 1, x to the n plus 3 over n plus 3. As I substitute the values in, we're getting familiar with this now. A 1 substituted into there will be 1 to the power of n plus 3, which we know to be 1, over n plus 3. And substituting in 0 to that expression will give me minus 0. Simplifying, I should get n plus 1 over n plus 3. And that's my expectation of x. Okay, and the final part of the question says, given that n equals 2. Okay, so I knew that the expectation of x was n plus 1 over n plus 2. The expectation of x squared, n plus 1 over n plus 3. When x equals 2, when n equals 2, the expectation of x will now be 3 over 4, and the expectation of x squared over 5. Okay, the question is asked for us to find the variance of 3x. First, I'm going to go ahead and find the variance of x. E of x squared minus the e of x squared. So we're looking at 3 over 5 minus 3 over 4 squared, which all works out to be 3 over 18. If we go ahead and use expectation algebra from S1, the variance of 3x equals 3 squared, the variance of x, which in this case is going to be 9 multiplied by 3 over 8. 9 multiplied by 3 over 80, which leads to our final answer, 27 over 80. Okay, you can leave that as a decimal if you like. That should be good for our answer.